Okay, so I'm going to be talking about a graph that's in this unit on carrying capacity and physical economy. So here it is. So just click here when you want to view it. I'm going to zoom in on it so we can look at it in some detail. We'll start with the first one. Um, but a note or two on the terms, carrying capacity and physical economy. If you look at this label down here, it says population and physical economy. Okay, so imagine you're thinking about, okay, there's a million people that live in a certain region, and by the way, these graphs can apply to a city, a state, a country, a planet, or anywhere in those ranges. Um, so the way this used to be used almost all the time was, okay, here's the population size, and so over time, it might change like this, and of course the axis over here would indicate how large that population might be. On the same axis, we're also graphing carrying capacity, but a different line. And the carrying capacity, the idea of that is in this case, the amount of population that could be supported in this given region over an extended period of time. And what we might note if we look down here a little bit is just that the carrying capacity itself can change. Okay, so if there's new technologies, maybe farmers learn to grow cover crops that make the soil more productive and more resilient and get better at preventing soil erosion, maybe they can increase the carrying capacity. In other words, the number of people that can be supported by the land in this particular case here. So this is kind of an optimistic graph. This one here, for example, the carrying capacity stays the same. Now, we can either use this for population or physical economy, but really physical economy in today's world is more important and something that we'll use this for because the physical economy not only takes into account the population, but also what that population is doing, their resource use, their management technique, all this sort of stuff is the physical economy. Okay. And so a population which lives very frugally, doesn't consume more than exactly what they need to get by and to reproduce themselves, would have a fairly small kind of ecological footprint, or if you want, a physical economy. They're closely related, not exactly the same thing. But so our purposes, we're thinking more about physical economy. Now, a lot of people will shy away from talking about population because some of the connotations are, oh, there are these poor regions of the world that are developing, and the real problem in the world is there's just too many people, and if we just had these people reduce their births, that everything would be wonderful. The problem generally with those kinds of analyses is that it ignores the size of the physical economy that those populations create. You probably know this. This is kind of a general scientific literacy piece, but just in case, the folks living in the wealthy regions of the world, like Western Europe and North America, Australia, New Zealand, and so on, Japan, and then some of the other smaller nations that have high incomes, they have a very high level of physical resource use per person to support their lifestyle. And that includes things like energy, materials, and so on. And even eating higher on the food chain can influence that. Eating beans, rice, and a few vegetables is very different from eating lots of beef every day, for example. So the physical economy is what we want to focus on. Remember, the physical economy is just the population times the resource use per person. And so they're closely related, but the physical economy gives us a better kind of insight into things. Okay, so all of that said, I would like to then look at some of these scenarios. And let's look at actually the second one here, if we may, for a little while. And I will need to kind of page down and over on that one. Let's just come down there. Let's just get it centered right here. So this is the one we want to look at. This is sigmoid growth. So remember, this is the physical economy, and this is the carrying capacity. Okay. And through time then, see, this is the axis of time, we can see that the physical economy comes up and approaches that carrying capacity but doesn't exceed it. How is that possible? Okay, so really important in these bottom three graphs, not the top one so much, but the bottom three, are the concepts of signals, as you can see right here, signals and responses. Okay, so like for example, they talk about responses here. Responses here are responded to immediately. Okay, so in this case, either they either just hope that they're not going to overshoot that carrying capacity and degrade it, so they limit themselves and they end up not degrading it, and so they kind of level off in a nice place close to that carrying capacity. That would be one possibility. Okay, this one here though, the physical economy grows and grows and grows, and it overshoots the carrying capacity. It can do that for a while, but let's say that it does that and it's eroding soil away or destabilizing the climate or something like this. So it overshoots, but eventually that degrades the resource. So what happens is the carrying capacity falls, doesn't it? Because the resources degrade. It can't sustain as much of a physical economy anymore, closely related to the population. Okay, so there's an overshoot, and then, well, we have to come back down because overall we can't sustain that. So the population, this is ugly, it hurts, right? It falls, so we overshoot, but then there's some resilience. The carrying capacity recovers. Maybe our technology improves a little bit as well. And so there's this kind of oscillation between the two where there's a little bit of an big overshoot first, and we don't overshoot by as much this time. There's a learning process going on. And so these become closer and closer to each other. The society learns. So, but this happens when the signals or responses are delayed. So maybe they overshot and didn't know it. Okay, or they knew it, and the scientists, the people who are paying attention to these kind of things, are saying, "Look, this is not sustainable. We can't keep doing that." But the powerful groups don't listen, and they keep doing, conducting business as usual, and so they degrade the resource. But eventually, this has to sort of, so to speak, come down to earth. Okay, in this case, it's also optimistic that those limits or the carrying capacity not only can be eroded, but more optimistically, it can recover. Okay, so that's a great thing. Now, the last one is kind of the doomsday kind of dark scenario, right? Look at this. So the physical economy overshoots, and that's maybe either the signals were delayed or the responses are delayed. And in doing so, it degrades the carrying capacity, which is then, as long as this stays higher than the carrying capacity, you continue to have resource degradation. And so now we find this new stasis at this much lower level. This is a disaster. Okay. Now, there are plenty of places in the world historically where this exact graph has happened. There's also places like this. Much of Northern Europe, going back several thousand years ago, went through cycles of deforestation, population decline, reforestation, rebuilding of soils, this sort of thing. So this is not based on, it's not hypothetical. If you study environmental history, lots of cases like this. Okay. In Southern Europe, on the other hand, for example, there was a lot of deforestation, and in many cases, the land, the forest never grew back. So you have a degradation of the lands in some of the Mediterranean regions. Okay, so this happens. Easter Island could be thought of as a case like this. If you've ever studied that out in the Pacific, that would be another case. Okay, so again, real key in all of this is the signals. How does this work? How do we get signals? Okay, so think about this. How does a society get signals that are overshooting? In modern days, we call that science. That's where we look at the indicators as scientists, and at some point we say, you know what, we have a problem here. The soils are eroded, or the fishery has been overexploited. So if you're a marine society based on mostly on fishing, and you notice the average size of fish declines and there aren't as many, maybe you've overshot. The North Atlantic cod fishery is this graph, okay? If you ever just studied North Atlantic cod fishery history, if you just Google that, you will see exactly what I'm talking about, okay? So we have plenty of both of these stories. This one here is less probable, and I guess it shouldn't be a huge surprise that that's true, because once we get used to a particular kind of level of consumption, people don't want to give up on that, and so we tend to overshoot. Or maybe it's because, again, powerful interests benefit from this additional level of commerce or resource exploitation, and so there's an overshoot like down here and here. But it's very hard to get a whole society to just decide, hey, we got the signals and we're going to do something about it before we overshoot them and degrade the resource base. So we'd have to have signals that are instant, accurate, and responded to immediately. Okay? Wow. Are we doing that in planet Earth today? I suspect that most of you would say probably not. However, there are some perplexing things that you have to confront when you think about these sorts of things. For example, using modern technologies in some places properly, you can increase the carrying capacity through various techniques, including cover cropping. And so it is possible to increase carrying capacity, and you might argue that in some ways humans have been able to do this. But the problem is very often we don't really get the signals right, and much of the story of global soil degradation is really more a story of this, or even that lower graph here. But one of the things that is interesting is that more and more of us have lived on the planet, and we're still feeding on a per person basis more food than ever. So it sort of implies that this is what's happening. One of the problems, though, with that is that we're not maybe listening to the signals either. And so that's a story which we could go a long ways with. And depending on what you guys vote on, I'm going to probably have you give me some feedback about what you want to do later on. We may or may not do something with that theme to a greater degree. But certainly one thing that influences carrying capacity is the environmental health. And if we have a climate which is destabilized, which is causing more destructive storms and so on, or just getting too hot in some areas and more severe droughts, as we've seen California had what was recently came out of what we call something like 1,000-year drought or more, kind of maybe a new thing in the environmental history of California that appears to be connected to climate change. And clearly for a lot of the state, there's been resource degradation, and there's been like an overexploitation of the even more limited water. In some areas, the carrying capacity as such might be reduced. Okay, so one of these lower graphs. Okay, so hopefully these concepts this is just kind of an intro to this, but clearly climate change is part of this. Areas that become deserts that didn't used to be, we could see a reduction in carrying capacity, maybe a little more like this. On the other hand, with climate change, some of the most northern areas, we might see something a little more like this, where they can now begin to grow grain in the northernmost parts of Asia and Canada. So while in the tropics and subtropics we see drought forcing people out, a lowered carrying capacity in places like northeast Brazil, the Sahel of Africa, just north of this, just south of the Sahara, and this sort of thing, we find in some places reduced carrying capacity, in other places an increased carrying capacity. The problem is in human societies, the populated areas are in those subtropical regions where the carrying capacity is being degraded. And do you think that the folks in Canada are really going to want a whole bunch of people migrating in from these subtropical areas, most of which are very low income of people? We'll see how that goes. But if you look at recent history, I would suggest to you that that probably isn't going to work out so well. So this is just a quick intro. Hopefully you'll find this useful. I would say this, for each graph, at least kind of have in your mind where signals matter and responses matter. How do we get there? Have some memory of this, study it a little bit, make sure it makes sense to you. I'll probably ask you a question or two or three on the quiz about that. Okay, thanks.